Yeah, so traditionally the observation was that there was a narrow interaction between the immune system and the course of melanoma, malignant melanoma, which is a skin cancer, and which is highly malignant. And only 10 years ago, the perspectives for a patient with metastatic melanoma were exceedingly bad, just like now still pancreatic cancer is. So the life expectancy at 1 year was only 25%, and at 5 years was 2-3% for metastatic melanoma. Now, 10 years later, and only because of immunotherapy and the breakthroughs that were initially discovered in malignant melanoma, we have 5-year survival rates of 60% and better. And so this is a true breakthrough. All the more so because this breakthrough has not been limited to melanoma, but the two key molecules that were discovered, which both got a Nobel Prize, the Nobel Prize of 2018, have been transversally active across multiple tumor types. And now we have approvals for anti-PD-1 as the main discovery, and anti-PD-L1 antibodies in over 20 different tumor types. So we now live in a different world. We live in the world where immunotherapy is a key component of any strategy for further therapeutic improvements, just about for any cancer. And it's just fantastic to be able to be part of those 10 years. Yeah. So we are now in a situation where the anti-PD-1 molecule is the central molecule on top of which we make combinations with other approaches. And the other approaches can be other immunomodulatory molecules like anti-CTLA-4 and all sorts of new discovery molecules, or vaccines, or even cytokines, everything that can interact with anti-PD-1 and further boost its activity. But it also means certain chemotherapies that lead to immunogenic cell death. It also means combinations with certain targeted agents where we can see very good synergistic interactions. On top of all these clinical trials that are now ongoing, between 1,500 and 2,000 trials are ongoing with the central key molecule anti-PD-1 or anti-PD-L1 in combination with something else. We have recently discovered that the microbiome, and especially the microbiome in the gut, sort of programs the capabilities of our immune system. And so often it's said you are what you eat, but you actually are what is populating your gut. Because what is populating your gut is programming the well-being of the body. And of course, here you are talking about trillions and trillions and trillions of different bacteria, and they determine what is the tonus, what is the level of activity capabilities of your immune system. And so if you have the wrong type of populations, or if you have been using broad-spectrum antibiotics too often or without any good indications, your microbiome in the gut can change. You can have a leaky gut, which lets into the body the wrong type of bacteria-associated molecules, and it can lead to all sorts of immune system suppression activities. And therefore, it's very interesting that there is now microbiome signatures, meaning certain species of bacteria that are associated with colon cancer. But there are other species that are associated with Crohn's disease, which is a colitis. There's other signatures associated with any chronic autoimmune disease or even Alzheimer. So what we have found out is that the gut sort of rules the well-being and the health status of the body. This also means we can manipulate and we can correct. So if you have the wrong microbiome, for whatever reason, we may be able to discover how to correct this and thereby help immunotherapies to further cure cancers, or how to avoid the emergence of autoimmune diseases. So the microbiome is going to play a very important role in the next 10 years and gives us another handle of how to keep people healthy, or how to make people healthy again. We already have fecal transplant treatments for patients with Crohn's disease, Crohn's colitis, to heal the colitis, so that they get rid of the wrong microbiome. You will see there will be, and we have the first clinical trials, that there will be methods over the next 5 years to be developed that help reprogramming the microbiome of cancer patients with different types of cancer. So it's a whole new world of complexity, but everything is in association with the immune system. The immune system is the central player that keeps our body in balance and defines how we fight off threats from outside or threats from inside, cancers, threats from outside, viruses, bacteria, and so on. So it's very exciting times. Tumors must be able to be recognized by the immune system for the ways they are different from normal cells. And in general, it's true that the more mutations you have accumulated, the more different recognition points you may have for the immune system. And we call the mutations leading to recognition molecules, we call those antigens. And the new ones that are induced by the cancer, we call those neoantigens. The more you have of those, the more points of recognition you will have for the immune system. So tumors with many, many mutations, like melanoma, like squamous cell skin cancer, like squamous cell lung cancer, especially the smoker lung cancers, like head and neck cancers, also many mutations, like certain subgroups of colorectal cancers, like bladder cancers, also associated with smoking. These are all tumors with high levels of mutations, therefore high levels of recognition molecules, antigens and neoantigens, and therefore you can interact and manipulate and enhance the recognition patterns for the immune system to fight these cancers. All these tumors were the first ones to demonstrate their reactivity to anti-PD-1 treatments. So anti-PD-1 is approved in melanoma, and in lung cancers, and in head and neck cancers, and in bladder cancers, and in renal cell cancers, and in certain types of colorectal cancers, and in any type of cancer with a very high mutational load, and so on. So this is the general principle on which we can enhance further recognition of tumors by the immune system. And this key molecule is anti-PD-1. And then all the other approaches may help to further explore and optimize immune system functioning. This is going to dominate for another 10 years completely the field. And then we may find different superseding regulatory mechanisms. And in a way, the microbiome is a superseding regulatory mechanism. So I predict that also microbiome research will be dominating over the next 10 years. It's very complex, but we can handle it with the current high-tech methodologies. Yeah.